The topic of the presentation is 3 challenges in implementing AI in the enterprise. And I'd like to welcome Sanjay Srivastava, who's Chief Digital Officer with Genpact. Sanjay.
Good day. Thank you for being here. We're here to talk about the 3 practical challenges we found in the work we're doing in implementing artificial intelligence, specifically in B2B enterprise environments. But by way of background before we get there, Genpact is a large global services provider of transformation services to really Fortune 500 corporations across the globe. We do that by using artificial intelligence, automation, and analytics capabilities. And we serve a variety of customers and many different industries across the world. One of the other responsibilities I have is actually looking internally into ourselves and taking the work we do and used to do and transforming that with AI and other capabilities. And as we work through that, we have come across challenges, we've learned a lot, and I'd like to share the sort of summary points of that with you. As I said, we serve clients with AI in a number of different areas. And the problem, as we run into in the pharmaceutical industry specifically, with regulatory compliance on adverse events, is that adverse events are exploding in depth, in content, in source, in media, in different ways they're getting published. And regulatory requirements are getting increasingly complex and differ from country to country. And so in that world, pharmaceutical companies are looking to harvest the data that exists and pull it up in a timely fashion and be able to draw insights from that, not only to report to regulatory authorities, but also to be able to draw signal noise and manage drug safety. The solution we chose in this case, using artificial intelligence, is to actually high-speed ingest all of the data that comes through, to run it through a semantic engine and extract the knowledge, disambiguating the adverse events, and then being able to extract the knowledge and classify it in a structured database, and then apply reporting on top of it so we can create this. And clearly the benefit we've seen is reduced costs, more efficiency, which is a natural. We've obviously seen accuracy go up, so quality is actually a big benefit here. But perhaps one of the best things we're starting to find is that the responsiveness of the system, the time that it takes to get it done, actually has practical implications for safety, because if we can detect problems quickly, our clients can address them faster. That's the world of pharmaceutical, and that's the capability around language processing and data science. I'll give you one more example from the wealth management field where we serve clients. And in wealth management, the problem is that you've got these large custodial statements, particularly in the institutional business, that come through. These are 60,000 documents a month. Each document has 600 pages. Each page has 40 different transactions. And the challenge is, how do you extract all that information? How do you convert it into meaningful knowledge? How do you apply a configurable analytics capability on top of that? And then how do you dynamically enable it for clients in that industry? And here the solution we've used, also with artificial intelligence, is computational linguistics. It's the ability to extract that knowledge, convert it quickly, and then apply configurable algorithms that can allow for performance analytics. And really the benefit, in addition to obviously reducing costs to making that process more higher quality, more accurate, is the fact that now the journeys of their customers, the experience of their customers, and being able to understand how their portfolio is performing is dynamic. It's real time. And being able to meet that has become a big driver for competitive differentiation in that industry. Switching from language and linguistics and financial numbers to the world of vision, computer vision, one of the things we do for insurance clients, and we've learned over time, is that when we have image, in this case of cars that have been damaged, and when we have claims adjustment information, in this case associated with the photographs that were taken by our clients, by ourselves in the process, and you take years of that data and you pull that in, and you run it through a neural net and develop an algorithm that can actually look at a photograph and predict the cost for the insurance adjustment claim that's going to come through on it. And this is technology that is allowing us and allowing clients to be able to reduce cost of claims adjustment, to reduce fraud in what happens in that industry, and to make that process more efficient. But what it really does is it changes the complete experience for the client's client on the other side. Because if you think about their journey, and many of us unfortunately have been through that journey, the ability to know where you stand, the ability to be able to get it processed quickly, and the ability to make it data-based is a very high satisfaction driver. And so we use this, and it's another example of AI at play in the enterprise in an industry we serve today. I'll give you two more examples, and I'm going to tell you some of the lessons we've learned through it. The first one is from consumer goods, sort of a manufacturing supply chain. It's a problem that shows up in many different industries. But in this case, in the consumer goods industry, the problem is the amount of choices you have to make when you get an order on where to source the raw materials. Think about the toothpaste you used this morning. And if I were the manufacturer of that toothpaste, where do you source the raw materials on the next order that comes through? Where do you actually manufacture it? Because clearly most companies have many different global manufacturing locations. How do you ship it from point A to point B? Which transit ports do you go through? Which countries do you pass through? And you understand embargo and trade and tax and obviously, unfortunately, a very current topic at the moment. And then when you get to this destination country, how do you have the right packaging? Because the packaging requirements are different. And if you had the wrong packaging, if it didn't state what needed to be stated, you could actually be banned from selling that toothpaste in that country for a month or so, right? So this is a very complex problem. It's happening at scale. It's happening in real time. And what we're doing here is applying actually machine learning. We're going back and looking at all of the shipping lanes, as it's called, the trade lanes, as it's called, that has to do with from and to, that has to do with packaging details and countries preferred and not, and shipping locations and tax codes and transit times and costs, and using all of that data to actually generate an algorithm and present it back to the user so when they get the next order, they're able to automatically apply it. And here's a great way that we've been able to put machine intelligence at play for what I think is a very tough problem because the numbers at scale here. I'll give you one last example just to set the backdrop, and then we're going to move on. And this example is from the entertainment industry. Obviously, as I look at customer intelligence, one of the challenges of customer intelligence is the fact that when you have a predefined set of options, and I think back to the last conversation you had with someone and said, well, I actually didn't like this. You know, the typical question is it this, A, B, C, D, and you pick a choice. It's a predefined option. When that happens, you actually lose the essence of the conversation and oftentimes the real root cause drivers of systemic issues. As an example, in this space, we went back and looked and worked with a client. We looked at the customer service results that they were getting. And then we said, actually, let's put that aside. Let's go back to the actual conversations. If it's in voice, we'll do voice to text. If it's already in a transcript, we'll just extract that and pull it into an AI system. And then we applied artificial intelligence to really understand what was being said, what was being heard, and uncover the true root cause drivers. And we found significant difference. You know, for instance, we find price as an issue, and oftentimes the conversation is, actually, I'm not getting value for the price I paid. But because price is one of 4 choices, it gets picked. Because value was not, it doesn't. And it takes the problem, it takes the resolution away from the real problem at heart. And so it's a great practical example on how in customer intelligence and uncovering the needs, we've been able to put that into play. And so as you can see, we've now been applying for the last few years artificial intelligence in what I would call enterprise, B2B environments. We don't serve startups at this time. We don't serve that part of the world, but we basically work with large corporations. And as we've done this work, there are, to be honest, some practical challenges we've run into. We've learned through them over time. We've actually found workarounds. But what I wanted to do with that backdrop is give you the 3 top sort of challenges in applying AI and implementing it in the enterprise. The first of those challenges is the notion of explainable AI. And very quickly, what explainable AI refers to is the traditional and often delivered answer to why is, trust me, it's a black box, actually does not work. Doesn't work for regulators that are looking to ensure that the decisions that are getting made are proper and correct. And frankly, even if it's not a regulator issue, the reality is for most enterprises, AI adoption has a curve to it. And part of the reason for the curve is change management. And part of the bump or the slow change management is because employees don't understand why. And just being told, well, trust it, it's a black box, actually doesn't work. So this is a real challenge in applying many AI techniques, certainly in regulated markets, but actually also in large, I'm not talking about POCs or pilots, in large enterprise-wide deployments. And the workaround we have figured around this, the learning that we've had, is this notion of design with the end in sight. And here's what I mean by that. When you actually think about applying artificial intelligence, it isn't about the technology, it's about the experience and the end result it generates. And if you start from there, you come to a very different answer. Example, we do a lot of work in the commercial lending industry. We help banks understand risk in inherent portfolios. We'll often take 500 balance sheets of a loan portfolio, and we'll extract the information and calculate a net risk score. Banks will use this to manage their portfolio risk and then be able to make appropriate decisions and track where the markets are. When we present that risk score, we actually allow the capability for you to click on it. And if you click on it, you drill down. So instead of just having one risk score as the end answer, thank you very much, now you have the ability to click on it and understand the component numbers. You take the fifth component number, and you say, well, that one doesn't look right. Let me click on it, and you drill down to the derivative numbers that delivered that sum or that average or that mean or that median, whatever it was that you actually clicked on. And then you actually look at that number, and you say, well, the seventh one looks really large. It looks a little bit out of place. I want to understand that. You click on it, and you can see how you're clicking and drilling. It actually takes you right back to balance sheet number 25, if that's the case, page number 19. It'll show the 3 lines that came through on the footnote from that page, and I'll tell you these are the 3 sentences that gave this result, and then this is how the result added up. And so this innate ability to track back, to click and drill, to understand the underlying reason why it's saying something, for us was a game changer. We've now applied these capabilities. We look at many commercial portfolios for some of the largest portfolios out there, and we find that it's easily adopted and actually very well-performing capability. And so the first one really is the world of explainable AI, and while AI catches up there, the answer we found is design with the end in sight. The second big block you have to work through, bump you had to pass through, we had to pass through, is that the B2B world is the world of low data density applications of AI. So when you think about Gmail, when you think about online commerce, when you think about ad clickstream data, right? You've got millions and millions and millions of data streams, and you can perform mathematical-based AI in a very easy fashion. But when you try and apply that in enterprises, it isn't always the case. For one, the data actually doesn't exist. And frankly, in many cases, the data actually exists. But because it's in a form that is traditional and has been around for a long time, converting, harvesting, wrangling, turning, and being able to extract that is a significant expense. And most companies aren't able to do that. So you have to live in a world of low data density in the B2B space, in the space of enterprise applications. And this is a big problem we sort of reached in the last few years as we were trying to apply AI in many different areas. And here's how we've solved for that problem now. We believe not all AI technologies are created equal. And the job at hand is to pick the right one for the right end result. So as an example, in the world of contract reconciliation, and we do this today, I have a real problem. I go to a client and I take no more than 50,000 contracts, best case. ideally we take 30, 40, whatever is available, 1,000 contracts. We take probably 1 million invoices. That's about the size of that corpus, as it's called in our industry. And the problem with that statement is that unlike large data applications, you can't throw a Stanford parser, you can't throw a Chicago algorithm on it to be able to understand what was said in the contract and reconcile it what you got billed for. You're going to pay 10 cents a mile, you've been charged 12 cents a mile over so many transactions, here's the overbilling that's happened, this is the reconciliation. How do you do that, right? That's a real problem because we just don't have the amount of data that's available to draw those conclusions. And the point I wanted to make here is picking the right technology is so important. So in the world of language, there is a set of technologies that are mathematics or statistical computing based. So statistical language linguistics, statistical linguistics is a big field. It's very well developed. We use a lot of it. And basically, that technology uses math to be able to compute. It's a vectoring technology on words. It's words vectoring is what it is. But equally, there's technologies like computational linguistics. And computational linguistics is a different approach. It applies AI to the structure, to the language, to the grammar, to the composition of words. And it uses AI in much the way a child would when they learn a new language. And so we apply computational linguistics, and we were able to actually unravel this problem, this mystery, and be able to deliver to that. And the point I wanted to make was there are actually indeed many different tools in the toolkit. Not all AI is created equal. And so we must spend time thinking through which ones to apply for which problem sets. And that's been a big learning for us, that we've stopped thinking AI is the solution. Let me go find a problem. And we've started exactly the other way around and said, here's the problem. What is the set of capabilities that allow us to deliver that? I'll probably give you the third, the thorniest, and perhaps for us today, the hardest problem to solve. And that is the fact that deep knowledge graphs are very difficult to find in the business world. We're all used to our Siris and our Alexas and Google Assistants and so on and so forth. And I can order a cup of Starbucks, or I can figure out where the next pizza is very quickly. But here's the reality today. If an 8-year-old child comes back from school and he tells his mother, Mom, I'm really unhappy, and the world is really unfair because Ben actually pushed me after class. I fell down. I got up, and I pushed him back. But the teacher didn't see him pushing me. She saw me pushing him. And so I got detention, and he didn't, and that's wrong. And I'll tell you, language aside, any 8-year-old in the world, anywhere, will understand exactly what was just said in a heartbeat. But there's no computer system today that can actually understand that because we don't get casuality, we don't get a sense of fairness, we don't understand equity in the concept of machine intelligence. And that gets back to the fact that our knowledge graphs today are fairly shallow. So when you translate the Alexa, Starbucks, coffee idea into the world of business, and then you say, where's the invoice for this order, and I'm going to dispute line number 6, and here's my reason for why that's happening. Can you tell me what you're going to do? Available knowledge graphs aren't sufficient. And so I think the solution that we found, and I think this is work in progress, is actually combining significant amounts of domain understanding and process data along with AI implementations. One of the different things we did for a client, this is amusement parks actually, is actually looking through the chatbot data and the interactions we were having with clients, with their clients, and really try and start understanding segmentation of that client base based on the conversations that were going on, and then using that to actually drive upsell, revenue optimization, offers, promotions, and those sorts of things. And here what we found was if you just run numbers math, if you just run artificial intelligence, you get a ton of information back, but you can't do anything without it unless you start superimposing on it the actual domain information that allows you to understand that at this point in the journey, it's after 3 o'clock, it's been a hot day, it's a family with 2 children, et cetera, this is the right offer to be offering them. And that domain knowledge is not in knowledge graphs today, and it has to be built and put around it. And indeed, some of the work we do, some of the work our clients do, some of the work I think others in the industry are doing are augmenting artificial intelligence capabilities with domain knowledge and process understanding so the two can come together and deliver a holistic experience. And I think that's a large part of how to crack the problem. So I've given you our sense of the top 3 challenges and a few thoughts on how we've tried to address it. I want to actually pull this thing together and quickly summarize for you. And the other reflection I have is, as we've gone through this journey in the last 4 or 5 years now, and we tried and tested and applied and piloted and POC'd many different capabilities and driven digital transformation for ourselves and for our clients. One of the foremost things that I've taken away from it is that digital, and in this case AI, is not a destination, it is a journey. And starting with the notion that we'll implement AI and then we'll be done with it is as wrong as it can get. And instead, the journey is about starting with a flexible digital platform that allows you to mix and match, to bring in new capabilities, to pick the right ones and apply to specific problems. And so this ability to have artificial intelligence, but core things like service orchestration, process automation, data analytics bundled together with a CX, a customer journey-oriented mindset, so it's market first as opposed to technology solution first, has been critical to us. And it's been one of the biggest learnings we've had as we've gone through these different intermediations or disintermediations we've done. And we pulled it all together internally for ourselves in what we call the Cora platform, which has analytics capabilities, artificial intelligence capabilities, and automation capabilities, and yet actually has a governance structure, a control and command mechanism as we get into the digital workforce, being able to do that. It has a modularity component, so you can mix and match computational linguistics with statistical linguistics as the case might present itself. And it has analytics capabilities because the core of it, AI is all about data, and it's about training or algorithms. And dealing with large data sizes is a large part of any AI journey. So it's a combination of those 3 sciences pulled together in a governance methodology, pulled together with modularity and integration into enterprise environments. And that's sort of how we've tackled the problem for ourselves. But in summary, look, here are the 3 key things I'd leave with you as you tackle the next AI challenge in your enterprise. Number 1, enterprise deployments are and have unique requirements. And we must start with that understanding first before we start throwing technologies at it. We've been very successful, by the way, with the technologies we've applied, but it's been through a very meticulous, rigorous journey to get there. Number 2, not all AI is created equal. Now, over time, I recognize that things will stabilize and maturity will reach its peak index and curves will flatten. But the reality is there is a curve today, and there is the scenario where not all AI is created equally, and picking the right one for the right job is as important as implementing it. And third, and perhaps the most important lesson we've learned, and one I'd pass on to you freely, is design with the end in sight. And when you think about applying AI, think about the application that pulls it together, think about the user experience that comes on the back of it, think about adoption curves and how you get utilization up, and then think about explainable AI as a large part of every project that we deliver to be able to make it usable in the enterprise. I'm going to end there. I hope this was helpful to you. We're all around the show, so we'd love to see you. We were big supporters of this AI Summit, and thank you for taking the time to listen to us.